In this video, this is something new that I'll be adding to our line of lessons. We'll be starting new topics in geology, grade 10 geology. Um, these types of videos will not comprise of so many um, equations and computations. We'll be basically tackling definitions on what we have to know about geology facts. So this topic is specifically set on defining terms related to Earth's moving surface. So, yeah, let's start. For plate tectonics, Earth's surface is broken into large rigid pieces that move. So these large and rigid pieces are what we call plate tectonics. They're basically the continental and oceanic crust on Earth. So the lithosphere is comprised of the crust and the uppermost part of the mantle. So basically, the lithosphere includes the plate tectonics as well as the uppermost mantle. As for the asthenosphere, it is the partially melted portion of the mantle that is located or situated below the lithosphere. In other words, it's the upper mantle. So let's discuss about the plate boundaries. So we have three: divergent, convergent, and transform. For the divergent plate boundary, it's the boundary where two plates move away from each other. So the motion is this way. So imagine that this is a plate and this is another plate. Whether it's an oceanic crust or a continental crust, the motion is that these two plates move away from each other. Hence, when the divergent boundary plate happens underwater, we form a submarine volcano. So, the product of convergent plate boundary occurrence on land are valleys. So, as you can see here in the not to scale illustration, these are the valleys that are formed. So, as you can see, it's not exactly a perfect drawing of what a valley looks like, but I suppose that you can see that if mountains are formed like this in basic drawing, valleys are drawn like this. So yeah. Um, as for the convergent plate boundary, it's basically the boundary where two plates move toward each other. So it's basically the perfect opposite of divergent plate boundaries, and hence, if valleys are formed in divergent plate boundaries, convergent plate boundaries form mountains. So two plates move toward each other and usually they form mountains. Or maybe if the plates are rather big or massive in size, they often create mountain ranges, not just a single mountain. So I apologize for my drawing. It's not exactly the best, but I hope it does clarify a few misconceptions. So for the third plate boundary, it's the transform plate boundary. It basically states that two plates slide past each other. So example, when we have one continental plate there and another continental plate here, if one moves this in this direction and the other moves in this direction, um, eventually convection would cause these continental crusts to be against each other, and the formation or the outcome would be rivers. I'm not sure if the rivers are formed that way, or maybe uh, I'm not exactly sure how rivers are formed in that sense, but I hope you do understand that transform plate boundaries are in this kind of situation and rivers are basically formed. So you have to know a few facts about this lesson. Plate movement is tracked to GPS. So this is something that Mr. Wegener, Alfred Wegener, the founder of the continental drift hypothesis, this is what he needed in order to justify his theory so that the scientific community would accept it. But unfortunately, um, the GPS wasn't invented during that time. It hadn't been invented yet. So yeah. For the Pangea theory, um, it basically states that Earth used to be one whole supercontinent before breaking apart. So this is what the Pangea theory is. So Eurasia is there, North America, South America, Africa, India, Antarctica, and Australia. So for the purpose of tectonic plate movement, it basically creates new landforms and waterforms through earthquakes. So earthquakes happen on the three plate boundaries. When an earthquake happens with a divergent plate boundary, um, as said earlier, it creates either submarine volcanoes or valleys. When earthquakes happen in convergent plates, mountains are formed, and for transform, earthquakes form rivers. And for the second purpose of tectonic plate movement, I suppose that these two purposes are not the only purposes. Maybe there are more, but these are what you basically have to know. For number two, it contributes to the existence of Earth's magnetic field. You might ask, what is the purpose of our magnetic field? Well, this should have been discussed in the next videos, but let me spoil it to you now. For the Earth's magnetic field, it basically serves as our shield from basically being fried, in informal terms, being fried by solar winds and cosmic rays. So these two forces come from outer space. They are extremely deadly to mankind. So the Earth's magnetic fields, the Earth's magnetic field deflects all these forces coming from the sun basically, and from other stars that um, the wastes basically, for some reason they enter the solar system, and for by chance they reach Earth. So the magnetic field of the Earth um, is formed thanks to convection. Convection is formed by, I mean, I'm sorry, convection forms earthquakes as well as the existence of magnetic field. So yeah, basically protects us from harm from outer space. Tectonic plates move through convection. As said earlier, convection is the reason for the movement of tectonic plates. And as for convection, the basic definition is that hot air rises and cold air goes down. This kind of system happens or is applied in the mantle, underwater, and at the atmosphere. So yeah, that's it for this video. Um, I hope you've learned something. So yeah, thank you for watching.